Hi, it's Mr. Castro once again, and today we're going to start talking about light. So like always, let's start by warming up our brain. What kind of waves have we learned about so far? And what is a mechanical wave? Pause, please. So what you should have come up with, you should have written things like sound and ocean waves and maybe earthquake waves, so we didn't talk about them too much. And also please remember that a mechanical wave specifically is a wave that requires a medium to travel. That's matter that the wave travels through. So our essential question for today is what happens to light when it interacts with matter? And what we will learn today, we will learn what are the properties of light waves, electromagnetic waves like light waves. What are the different kinds of electromagnetic waves? And what happens to an electromagnetic wave when it comes in contact with matter? Vocabulary for the day, we have the electromagnetic spectrum, ray, reflect or reflection, absorb or absorption, transparent or transparency, translucent, opaque, refract and refraction, angle of incidence, angle of reflection, normal line, interface, and total internal reflection. So let's start with what light is. Light is an electromagnetic wave. This means that while it can travel through a medium, it can also travel through a vacuum, which is why you can see sunlight. Sunlight has to travel through the vacuum of space. Light is also a transverse wave, which means that while the wave goes this way, the oscillation goes this way. As we have already learned, the amplitude of light controls the frequency. The amplitude of light controls the intensity of light, how bright it is. As bright lights have high amplitudes. Wavelength and frequency control color. The red end is the low frequency long wavelength end. The violet end is the high frequency short wavelength end. Visible light, though, is only a small part of the electromagnetic spectrum, and it's all really light. Visible light is just different mostly in that those are the wavelengths we can see. Lower frequencies include radio waves, microwaves, and infrared light. Some forms of light with shorter wavelengths and higher frequencies include ultraviolet light, X-rays, and gamma rays. Here's a diagram of the electromagnetic spectrum. So you can see radio at the long end, gamma rays at the short end, and visible light is right here, right in the middle. So what are the properties of light? The speed of light, including all electromagnetic radiation, is 3 times 10 to the 8th meters per second, which is 300 million meters per second, which is 186,000 miles per second. If I turned on a flashlight, the beam would travel around the Earth 7 times in 1 second. Like all waves, light travels in a straight line unless it bumps into something. We call the lines that light travels along rays. Remember that in math, a ray is a line that starts at a point, but ends, but doesn't end. So the other end is an arrow. Okay. Red light has a frequency of 430 terahertz. That means 430, every second, 430 trillion red light waves pass your eyes. Violet light's frequency is even higher. It's 750 terahertz. Now, red light has a wavelength of about 750 nanometers. That means each wave is about 700 million nanometers. That means each wave is 700 billionths of a meter long. Violet light is even shorter. It's about 400 nanometers. Even so, notice that visible light is near the middle of the electromagnetic spectrum. So you see red here with a lower frequency but a longer wavelength, and violet with a higher frequency but a shorter wavelength. What happens when light interacts with matter? 4 things can happen. First, it can just keep going. We call this transmission. Secondly, it can bounce back. We call this reflection. I taught you reflection already. Third, it can get sucked in and stop. We call this absorption. And finally, it can change its path because it's being bent. We call this refraction. So transmission, reflection, absorption, refraction. When we talk about matter reflecting and refracting and transmitting and absorbing, there are 3 adjectives I want you to know. When light just goes through, transmits, we say that the substance is transparent. When we say light passes through, but only certain colors or some of the light passes through, we call that translucent. And when none of the light passes through because it's either all being reflected or absorbed, we call that opaque. The rules of reflection depend on a few vocabulary words I want you to know. First of all, light that is coming in is called, at an angle called the angle of incidence. We call that light coming in, going in, the line, the incident ray. The light going out is called the reflective ray, and the angle at which it comes out is called the angle of reflection. And this line right in the middle, that's called the normal line. And the normal line is perpendicular to the mirrors or whatever is reflecting. The normal line is perpendicular, so we have the incident ray. You can see the light coming in. You see light coming out, that's the reflected ray, and right in the middle is the normal line, and the angle between the incident ray and the normal line is the angle of incidence. The angle between the normal line and the reflected ray is the angle of reflection. And the rule is very simple. The angle of incidence equals the angle of reflection. So whatever is coming in is coming out at the same angle. That's the rule. So what about refraction? Take a look at this pencil. You'll see it looks broken. Of course, it's not really broken. What's really happening? Well, the light is coming in, the water is transparent, so all the light coming through, but air is a different medium from water. We call the border between the air and the water, or any 2 media, we call that the interface. And when that happens, the speed of the light actually changes, and that causes the path of the light to change. We call that refraction. How much the light bends depends on the kind of medium and the angle of incidence. We call the refractive ability of a substance, we call that the index of refraction. But what is more important is as the angle of incidence gets closer to 90 degrees, it refracts more. So if it's going a very low angle, it just keeps going straight ahead. If it goes at an angle close to 0, it won't refract much. However, if you get to a point around 50 degrees, it doesn't refract anymore. It reflects. We call that, see here, this point here, it's reflecting. We call that total internal reflection. So here's a diagram so you can see going straight no refraction. However, if you're going at a little bit of an angle, it bends it more and reflects a little bit. That's the angle of refraction. Here again, angle of incidence, angle of reflection, angle of refraction. These last two, all it's doing is reflecting. We call that total internal reflection. And that's all we've got for today. I hope you had fun. I sure did. Have a great one.